So first problem is to find the gauge pressures and absolute pressure at the bottom of the tank. So here this is the problem where a tank consists of three or more liquids. Here we have three liquids, where in the bottom we have carbon tetrachloride of specific gravity 1.7. Similarly, we have above that we have water. You know that specific gravity is 1, so the height is 1.5 meters. Similarly, on the top portion we have oil of specific gravity 0.8 for a height of 1.2. So you're required to find the pressure at the bottom of the tank, that is at E. So here in terms of gauge units as well as in the absolute units, you know that whenever you take atmospheric pressure as datum, the pressure that is referred to it is known as the gauge pressures. So when you take absolute zero as the datum, then it is known as absolute pressure. So we had a relation that absolute pressure is nothing but atmospheric pressure plus or minus gauge pressure. So here, in order to solve the problems, we should know the pressure at any reference point. Since the pressure at D is exposed to the atmosphere, so pressure is zero in terms of gauge. So therefore, if you want to measure the pressure in gauge units, then atmospheric pressure is taken as zero. So therefore, we also know that as we move downwards, the pressure goes on increasing. So therefore, if the pressure is zero here, so by the time you come here, so the pressure is P is equal to omega into H. So what is omega here? It is specific weight of oil. So therefore, you have to take specific weight of oil. You know that specific weight of any liquid is specific gravity into specific weight of water. So with this concept, so now zero, so as we move downwards, pressure increases. So the pressure here will be 0 plus 0.8 into 9.81 specific weight into 1.2. So we'll give the pressure at C. So as I told you that the pressure at D is 0 because it's exposed to atmosphere. So now pressure at C is nothing but pressure at D plus omega into H. So what is this omega? It is nothing but specific weight of oil. So therefore specific weight of oil is 0.8 into 9.81, whereas the depth is 1.2. So therefore the pressure at C is 9.418. So now, so when we move from C to D, so the pressure at B is nothing but pressure at C plus, okay, omega into H. So what is specific weight here? It is specific weight of water. So specific weight of water is 9.81. So 9.81 into 1.5. So therefore pressure at B is 9.418 plus the okay. So here the specific weight of water is 9.81, depth is 1.5. So therefore the pressure at B is 24.13 kilonewton per meter square. Similarly, now the pressure at A, which is at the bottom of the tank, is pressure at B plus, because as we are moving downwards, so specific weight is 1.7 into 9.81. If you multiply by H, that is 2, so you will get the pressure at A. So therefore, the pressure at A is 24.133 plus 1.7 into 9.81 is specific weight into 2 is the height of the liquid. So that gives the pressure. So since we had taken 0 as atmospheric pressure, so therefore all these units 9.418 or 24.133 or 57.48 will be in the gauge units. So therefore these are all gauge pressures. But also absolute pressure is asked at the bottom of the tank. So you know that absolute pressure is nothing but atmospheric pressure plus gauge pressure. So here we know that in absolute units atmospheric pressure is nothing but 101.3 kilonewton per meter square. So therefore, so atmospheric pressure you substitute as 101.3. Gauge pressure you know that it is 57. So it is 57.48. So therefore the total is 158.78 kilonewton per meter square. So this is in absolute units, this is in the gauge units. So second problem is we have a closed tank of 8 meters height is filled with bromine of specific gravity 3.1 to a depth of 2 meters and turpentine of specific gravity 0.87 to a depth of 5 meters. So the upper part contains air under pressure which is of 25 kilopascal vacuum. So to find the absolute pressures at the bottom of the tank in kilopascal as well as in centimeters of mercury. Okay, so here, so this is the okay, so we have 8 meters height tank. So as I told you that there is a bromine of specific gravity 3.1 for a height of 2 meters, and then we have turpentine for a height of 5 meters for the turpentine specific gravity is 0.87. So 5 plus 2 7. So but the total height of the tank is 8, so therefore remaining 1 meter is filled with air under pressure, which is exerting a pressure of 25 kilopascal vacuum. So pascal is nothing but Newton per meter square. So kilo, so that will become uh, kilonewton per meter square. Vacuum indicates that it is negative gauge pressure. So therefore the pressure at A will be now minus 25 kilopascal. Okay, so now it cannot be taken 0. Here the pressure here will be minus 25 kilopascal. So then minus 25, as we move downwards pressure increases. So it is minus 25 plus what is specific gravity 0.87 into 9.81 into 5 meters. Then we'll get pressure at B. Similarly, if you want to find pressure at C, then pressure at B plus 3.1 into 9.81 is specific weight into 2 meters. So that gives the pressure in kilopascal. That is because everything is measured in kilonewton per meter square. So kilonewton per meter square is nothing but kilopascal. So now you know that pressure at A is 25 kilopascal vacuum. Vacuum indicates that it is minus, so it becomes minus 25 kilonewton per meter square. Now if you want to find the pressure at B, it is pressure at A. As we move downwards, pressure increases, so plus sign. So plus 0.87 into 9.81 is specific weight of turpentine, and then multiply by 5 is for H. So therefore we will get minus 25 plus 0.87, 9.81 into 5 gives 674 kilonewton per or kilopascal. So similarly the pressure at C will be pressure at B plus the specific weight of bromine is 3.1 into 9.81 and 2 is for the height. So therefore the pressure at C is 78.496 kilonewton per meter square. So kilonewton per meter square is also nothing but kilopascal. So what is the absolute pressure now? So the gauge pressure at C is 78.496, but atmospheric pressure is 101.3 kilonewton per meter square. So 101.3 plus 78 will give 179.8 kilonewton per meter square as absolute pressure at C. So this is what is in the unit kilonewton per meter square is nothing but Newton per meter square is Pascal. So it is also kilopascal. So now in order to convert into centimeters of mercury, you know that the absolute pressure should also be in centimeters of mercury. So P is equal to omega into H. So now here H is asked, which is in centimeters. So we know the pressure is already 179.78 divided by specific weight of mercury. If you divide specific weight of mercury, then you will get meters of mercury. So then you can multiply by 100 to convert into centimeters of mercury. So therefore absolute pressure at C is also 179.796 divided by specific weight of mercury, that is specific weight of mercury is 13.6 into 9.81, so 1.348 millimeters of mercury will be the answer. So then if you multiply by 100 you will get in centimeters of mercury. So therefore in whatever units you want you can convert it. If it is centimeters of say turpentine, you can divide by specific weight of turpentine. If you want in centimeters of bromine, then you can divide by specific weight of bromine, so that you will get in meters of liquid, that particular liquid. So since I'm dividing by the specific weight of mercury, I will get the answer as meters of liquid, which is mercury here. So therefore I have written as meters of mercury. So since the answer is asked in centimeters of mercury, so you have to multiply it by 100 so as to get as centimeters of mercury. So therefore absolute pressure in kilopascal is determined. Absolute pressure at the bottom is also determined in centimeters of mercury. So next problem is to find again the gauge pressures at the bottom of the tank. So here very interesting problem is that here a manometer is connected. So that means a U-tube manometer is connected where one end is exposed to atmosphere. So whereas the other end is connected to the pressure point. So air is under pressure here. So therefore, so whatever the because of this, so the liquid gets displaced here, and so that we are able to find out the pressure at point B. So in order to get the pressure at A, that is bottom of the tank, we should know what is the pressure at B. So the pressure at B is determined by means of this manometer. So I also told you the principle behind the writing the manometric equation. So I had I had derived that dou P by dou X. Okay, dou P by dou X should be equal to 0. So this indicates that the pressure at any horizontal level for one continuous liquid should be constant. So here you can find that, so this is a one continuous liquid, so which is a mercury. Okay, so here and one horizontal plane, so that means D and D dash are in one horizontal line. So therefore whatever the pressure at D should be equal to pressure at D dash, because it is one continuous liquid. You cannot equate pressure C to be same as here. Okay, so here it is atmospheric pressure. It cannot be atmospheric pressure here, because here we have air and then the liquid starts. So there is not one continuous liquid. Okay, but when you come to D and D dash, it is a one continuous liquid. Okay, if this is mercury, here also it is mercury. So it should be a one continuous liquid. So then you can equate the pressures. And so you cannot equate the pressure here, because here it is oil and here it is mercury. So you cannot equate like this. So you have to have one continuous liquid like this. So then only you can equate pressure at D should be. So now the so what is pressure at D? So since it is exposed to atmosphere, so pressure at D will be equal to 0. So therefore the pressure at D dash will be equal to 0. So now we know that as we move upwards, pressure will decrease. So therefore it will be 0 minus omega into H. So what is specific weight of mercury? It is 13.6 into 9.81. So 13.6 into 9.81 into 1.1. So we'll give the pressure at C. So once you know the pressure at C, so this is again one continuous fluid, that is air. So therefore the pressure here will be, okay, which will be or whatever the pressure at C. So if once you know that as you move downwards the pressure will increase as we move downwards pressure. So now you know the pressure here, because it is same as pressure at C, because it is one continuous fluid. So now but here if you come down, so you have to multiply by omega into H. So okay, this H is the height of the air, and specific weight of air is too negligible. So hence therefore whatever the pressure that you get here can be written as pressure at B. So therefore the pressure at B can be written directly equal to pressure at C by this concept. Okay, so that's what I'm going to do there. Once we get the pressure at B, then we can find out the pressure at A. As we move downwards, pressure increases. So you can add specific weight of oil and multiply by 3 meters. So then you will get the pressure at A. So now as I told you, the pressure at D is exposed to atmosphere, so therefore it is 0. So therefore pressure at, because it is one continuous liquid, so pressure at D dash has to be equal to pressure at D. So which is 0. Now pressure at C is nothing but pressure at D dash. As we move upwards, pressure decreases, so it is omega into H. So but here it is mercury, so it is 13.6 into 9.81. So if you multiply by 1.1, you will get pressure at C, which is minus 146.76. So you know that the pressure at B has to be equal to pressure at C, and which is nothing but minus, okay, minus 146.76, as I told you that. So if you know the pressure at C, which is minus 146, it will be because it is one continuous fluid, which is air. So here the pressure has to be same. So I will take this as something like C dash. So the pressure at C dash has to be equal to pressure at C. So therefore now pressure at C dash will now become equal to minus 146. So minus 146.76 minus 146 point. As we move downwards, the pressure increases. So it is omega. So here it is air is there. So specific weight of air. So multiply by H. So as specific weight of air is negligible quantity, so therefore the value whatever at pressure at C dash was 146 minus 146 will become the pressure at B. So therefore the pressure at B is directly taken equal to pressure at C, which is minus 146.76. Now you can find the pressure at A. So pressure at A is minus 146.76 plus, because as we move downwards pressure increases, specific weight of oil is 0.8 into 9.81 and H is 3. So therefore the answer is minus 123.22 kilopascal or kilonewton per meter square. So the gauge when you fit at the bottom of the tank will read minus 123.22 kilopascal. So that is what is known as the gauge pressure. Why gauge pressure? Because here we have taken as 0, because atmospheric pressure is taken as 0 in gauge units. So next problem, as shown in the figure, the pipe and the connections are full of oil of specific gravity 0.9. If the U-tube manometer contains mercury, you have to find the elevations of the point A in the pipe. So this is the problem which is given. Here we have a pipe which is running here. So that is connected with a gauge, so which will be reading 3 into 10 raised to 5 Newton per meter square. But you know that the oil is flowing. So whenever you connect a manometer here, so it is a U-tube manometer where one limb is exposed to atmosphere. So once it is exposed to atmosphere, you know that the pressure at this point is 0 in gauge units. So you know the pressure here, okay, and you know the pressure here. Okay, so pressure at A is 3 into 10 raised to 5 Newton per meter square. So now we are required to find what is the elevation of the point A. So in order to find the elevation of point A, so 1 meter 1.1. So only thing is this distance has to be determined. So now you know that the pressure always depends upon the vertical distance. So therefore this inclined distance is no use to us. So whenever we want to find the pressures at any point, so we have to move vertically upwards or downwards. So therefore the vertical height is marked rather than the inclined distance. So therefore I have taken, if I know this h, I'll be able to find the elevation because it is 100, okay, plus 1.1 plus 1 plus h. So that I will get the elevation of point A, since I know the elevation 100 here. So for this, in order to find here, so we should have again the manometric equation, which is one continuous liquid. So you can see that since the distances are already marked here, so it is always better to take the pressure at D should be equal to pressure at D dash. It is no harm that you can take even pressure, because at C should be equal to C dash. So only thing is you should deduct 1.1 for 4.18 and write. So even you can write even here also, because it is all one continuous liquid. Either you write pressure at C equals pressure at C dash, or you can write pressure at D equals. So I don't want to change anything. So based on this problem, which is already marked 4.12, so I want to take the pressure at D equal to pressure at D dash. So now if you want, so once you equate this, then this h gets solved. So this is so simple. So here, so pressure here is 0, so right hand side. So then as we move downwards, pressure increases, so it is 0 plus, okay, what is specific weight of mercury? 13.6 into 9.21. H is 4.12. So you will get pressure at D dash. Now you come here. So once you know pressure here, because it is already given here, which is 3 into 10 raised to 5, you can convert that into kilonewton per meter square. So everything is converted into kilonewton per meter square. So you divide by 1000. So 10 raised to 3. So it will be 300 kilonewton per meter square. So that, okay, so as we move downwards, pressure increases. The pressure at A plus what is flowing? So oil is flowing. So therefore 0.9 into 9.81 into H. Then you get here, then plus, okay, so everything is oil, so oil goes here and displaces. So therefore from, because when you come, now you have come to this point, so now pressure B will be equal to pressure here, so it is one continuous liquid. So you can move from here down, so that will be specific weight of oil is 0.9 into 9.81 into 1. Then as you move downwards again, because here it is mercury, so you should write 13.6 into 9.81 into 1.1. So you will get pressure at D. So now equate and solve for H. So that's what then. So pressure at A is 3 into 10 raised to 5 Newton per meter square. So divide by 1000, so we'll get 300. So everything should be in same units. So 300 kilonewtons. I am working in kilonewton per meter square units. So therefore it is 300 kilonewton per meter square. So pressure at D has to be equal to pressure at D dash. So how to write the equation? So you start first here 300. So now as we move downwards, pressure increases. So therefore I have written the specific weight of oil, which is 0.9 into 9.81 into H. Then we move again downwards, but you see that there is oil up to point C, so therefore 0.9 into 9.81, but the height covered is 1 meter. Then when you move from C to D, then it is mercury, so we write as 13.6 into 9.81, H is 1.1. So now we got pressure at D. Similarly, if you want pressure at D dash, so we should start from 0, so 0 because it is exposed to atmosphere, plus 13.6 into 9.81 is specific weight of mercury into 4.12 is the distance. So now we have wrote the manometric equation. So only unknown is H, so it gets solved. So therefore solving, so we get H equals 10.66 meters. So therefore we can find out the elevation of point A. So the elevation of point A, you start from D and move upwards to A. So elevation of point A is 100 plus 1.1 plus 1 plus H. H is 10.66. So therefore the elevation of point A is 112.76 meters. So very interesting problem. So where we are making use of the YouTube manometer, and also we are writing the manometric equations, and we are equating the pressure at D should be equal to pressure at D dash, because there is one continuous liquid and one horizontal plane where the pressures are same. And also here the pressure always depends upon the vertical distance, so therefore inclined distance is never marked here. So whenever you want to find out the pressure at B from pressure at A, you have to move vertically downwards, and that's the reason why H is marked as a vertical distance. And then only we can write pressure at B as pressure at A plus, because we are moving downwards, plus specific weight, what is flowing, oil, 0.9 and 9.81 into H. So now we have come to point B. From B to C we have to, so since oil is flowing, so again specific gravity is 0.9 into 9.81. Then when moving from point C to point D in the left limb, we have mercury, so therefore 13.6 into 9.81 is the specific weight of mercury. But on the right hand side we have mercury, so therefore specific weight of mercury is 13.6 into 9.81, which is multiplied by 4.12 as H. So therefore solving this we get H, and so that will enable us to find out the elevation of point A. Again a similar kind of a problem where we have in the left hand tank as shown in the figure, air pressure is given, which is 0.23 meters of mercury, which is vacuum. Again it will be minus 0.23 meters of mercury. We have to find the elevations of the gauge liquid in the right hand column at A if the liquid in the right hand tank is water. So this is the problem that is given. So here the air pressure is given, so which is minus 0.23 meters of mercury. So you can always convert to kilonewton per meter square units, because we are working in kilonewton per meter square. So but here it is required to find what is the elevation of this particular point. Since the elevation 105 is given, so as we move downwards we come to 100. So 100 minus H will give elevation of. So only thing is we have to require to find this value H. Okay, so how to find value H is that again we write at the here is a one continuous liquid, which is liquid of specific gravity 1.6, but should be one horizontal plane. So now here pressure at A has to be equal to pressure at A dash. So because it is one continuous liquid, so you start from D and come down towards A, you will write an equation on the right hand side. You start from C and come down vertically downwards, because now again inclined distance are not there, so vertically downwards, that is H. Okay, and then come down to point A dash. So when you equate left hand side equal to right hand side, then you can solve for H as we did in the previous problem. So only thing is here the distances are known, so from here onwards here entire thing is oil. So for 5 meters it is oil,
For 5 meters it is oil, and then for H meters it is liquid of specific gravity. Similarly here, from 102 to 100, that is about 2 meters, it is okay. On the right hand, you have to have whatever here, okay. So this is if the liquid in the right hand tank is water, so this is water, so this is water. So specific gravity is, so from 102 to 100 it is water. Again for H meter on the right hand side is water. From A onwards the gauge liquid will start, okay, up to 100. So therefore whenever you write, the proper specific weight should be taken. So what is pressure at sea? Pressure at sea is given as 0.23 meters of mercury, which is vacuum. So we write it as minus 0.23 meters of mercury. But we want to convert this, because it is meters of mercury, we multiply by omega, which is the specific weight of mercury. So specific weight of mercury is 13.6 into 9.81. So when you take 13.6 into 9.81 and multiply by H, it will become kilonewton per meter square. So that's the reason why 0.23 meters of mercury is converted to kilonewton per meter square by multiplying by specific weight of mercury, because it was given as meters of mercury. Okay, suppose it's 0.23 meters of oil is given. So what we do is minus 0.23 into oil, say 0.8, 0.8 into 9.8. Then it will become kilonewton per meter square. So you have to see which meters of liquid, and corresponding specific weight has to be multiplied. So therefore, since it was meters of mercury, we multiplied by specific weight of mercury to convert into kilonewton per meter square, so that we can work in kilonewton per meter square units. So this was the pressure at C. Similarly, reference pressure at here at B was also given. So you know that the pressure at D is given, which is 2.06. So what? So since it is air, okay, here, okay, it is not because the air pressure is given here, which will be acting on point B. So for the pressure at B will be equal to 2.06 10 raised to 4 Newton per meter square. You can divide by 1000 to convert into kilonewtons. So therefore the pressure at B is nothing but pressure at D, which is given as 2.06 in 10 raised to 4. You can divide by 1000, so to convert into kilonewton per meter square, which is 20.6 kilonewton per meter square. So now you know the references points on the left limb as well as on the right limb. So you start writing the pressure equations, that is you equate manometric equations, that is pressure at A should be equal to pressure at A dash. So left limb is pressure at A dash, right limb is pressure at A. So you start from C, that is minus 30.69. So minus 30.69. As we move downwards, pressure increases. So 5 meters is the oil specific gravity. So therefore it is 0.8 into 9.81 into 5. So now we have to move down from 100 to A dash. So here the liquid is liquid of specific gravity 1.6. So therefore specific weight is 1.6 into 9.81. The height is H. Height is H, so therefore it is H. So we have come down to A dash. So now we have to start from D. So and write an equation. So 20.6 is the pressure here, so which is same as at 102 level. So therefore 20.6, as we move downwards, the water is there up to A. So therefore it is 9.81 up to 100, that is 102 minus 100 is 2 meters. So 9.81 into plus again 9.81 into H, because this is water. So now the only unknown is H everywhere, so you can solve for H. So solving, we get 5.38 meters of that liquid. So therefore here so H is 5.38. so we, in order to find elevation here, so 105, okay, so here this is 100, so 100 minus H will give elevation. So therefore elevation of point A is 100 minus 5.38, which gives 94.62. So again the problem is slightly similar to the previous problem, except
that here there elevation of point was asked, here also elevation of point was asked, but only thing is, please remember here that there are the pressures at in both the compartments were given. So in the previous case it was exposed to atmosphere, here actually pressure is given, which is measured by this gauge, and so that becomes the air pressure on point B. So therefore, and here also the air pressure was given, and it was given as negative pressure. So therefore we have taken as minus 0.23 meters of mercury, which was converted to kilonewton per meter square units. So very interesting problem. So this also can be made, you are using those concepts only, we are writing the equations. So again, in the manometer shown in the figure, the liquid in the left hand tank is carbon tetrachloride of specific gravity 1.6, and the liquid on the right hand side is mercury. If the pressure difference is 5150.25 Newton per meter square, you have to find specific gravity of the liquid. So this is the problem where again we have two limbs which are connected by a manometer. We are required to find specific gravity of this liquid. So the pressure difference between the point A and point B is given, which is 5150.25 Newton per meter square. You have to find specific gravity of this liquid. So all the distances are given. So a zero scale is also given. So now you can equate at this particular level. So if you can start from B, okay, so we have to move along this, okay, and come to one reference point. So now we can see that, see here, say this is one continuously, so somewhere you have to find, so this is one continuous liquid, so this is liquid X, and stop, see here, so when you take pressure at D, it has to be equal to pressure at, we cannot take pressure at C equal to C dash here, because it is not continuous liquid. So if you're moving from here, so from D dash you can come to D, but wall is one continuous liquid but one horizontal plane. So you can equate pressure at D equals to pressure at D dash. So you can start from B and come down to D dash. You can start from A and go up to D, so that you can equate these two and solve for any unknowns. So now the difference of pressure is 5150.25. So that if you divide by 1000, it will be 5.15 kilonewton per meter square. So as usual, you write pressure at D equals pressure at D dash. So here first I will find what is pressure at D. So what is pressure at D? It is pressure at A. So as we move downwards, pressure increases. How much? Okay, so 0.95. What is there? Carbon tetrachloride. So 1.6 is carbon tetrachloride specific gravity. So 1.6 into 9.81 into 0.95. Now we have come to this level, you go up by 0.9. So again carbon tetrachloride is there. So that minus 1.6 into 9.81 into 0.9. So as we move downwards, pressure increases, so plus sign. As we move up to move towards D, then we have to write negative sign. So this will be the pressure at D. So similarly, if you want pressure at D dash, you start from B. So pressure at B, that is PB. So now we are moving, say here it is mercury, so 13, so we are coming down, so therefore pressure increases, so 13 plus sign, 13.6, 9.81 into 0.85, this distance is used. Now we have to go up to this, but the liquid changes again, so only 0.8, so it is minus sign. So minus 13.6 into 9.81 into 0.8. So what is remaining? 0.1 is remaining. So that is of liquid of specific gravity X. So again you move up. So specific gravity of that liquid into 9.81 will give specific weight. So multiply by 0.1. So then we obtain the pressure at D dash. So you know that pressure at D should be equal to pressure at D dash. Equate these two. So if you equate here, so if you equate it, so you will get something like this. Okay, so you try to equate these two and try to simplify all these answers, so you will get this. So specific gravity, okay, 5 1, so pressure at, so PA minus PB is nothing but 5.15, which is where you can solve for specific gravity. So specific gravity will be like something like
So now what I have written is that I have already solved this. So you write this equated to this and simplify. So do all the solutions. So just try to solve this, and I have written directly this value. Okay, so 5 points. So wherever Sx is there, that is 9.81 into 0.1 is 0.981. So I have written 0.981, and this all this I have tried to solve it and written as 5.886. Then I substituted for Pa minus Pb. So I have brought so once I have equated these two, so I have brought this to the left hand side, so it has become Pa minus. All other things I have brought it to the right hand side and solved for here. Okay, so therefore be careful. So this equation is equated to this equation, and I have brought only PB this side to the left hand side, and 1.69.2.95 brought right hand side, minus is brought as to the right hand side as plus, and then I solved it and written as 5.886. So therefore specific gravity now is 0.75. So now you can note that specific gravity is lesser than here. Okay, because it is inverted, so it can stand. So that's why the specific gravity of this is always lesser than the carbon tetrachloride. Okay, so you should not get answer something like 1.8, which is absurd. So here it has to be lesser than carbon tetrachloride. So therefore the answer you got is 0.75. So determine the pressure difference between two pipes A and B as shown in the figure. The specific gravity of manometric liquid is, so manometric liquids is that which when it displaces, when you try to measure the difference in the liquid levels, it will be unable as to find out the pressure difference between two points A and B. So this is the problem here. The two pipes which are running here like this A and B are connected by this manometer. So you know that so whenever we connect this manometer, so there should high pressure liquids will enter and try to displace this liquid. So here the displacement is given as 0.3 meters, which is given here. Okay, and the difference between A and B is also given 1.25, and this difference is also given as zero point 0.5 meters. So here manometric liquid is this, which is of specific gravity 0.9. So we have to find the difference of pressure between these 2 points. So whenever such problem is given, so we should note that it is one continuous liquid and on one horizontal plane where pressure is same. So we have to equate at C and C dash because it is one continuous liquid. So we cannot equate, because from here if you move, so there will be water here. So we cannot equate at D level. We have to equate at C level only, because it is manometric liquid at C and C dash. So therefore you start from A, move upwards to C. You start from B and move towards C dash. So if you equate these pressures, then you are able to find out the pressures at A and B. So let the pressure at A be PA, let the pressure at B be PB. So now you can start writing. So here the pressure at C, how to write pressure at C? It is nothing but pressure at A. So as we move upwards, pressure decreases. So the distance is 0.8, but it is water. So it is 9.81 into 0.8. So how to write pressure at C dash? So pressure at C dash is PB. So when it is one horizontal plane. So as we move upwards up to distance of 1.75, so it is water. So therefore 9.81 into 1.75, minus is for as we move upwards pressure decrease. Again we move upwards, but specific gravity here is manometric liquid. So here so therefore specific gravity is 0.9. So if you 0.9 into 9.81 is specific weight of this manometric liquid, the distance is 0.3. So this is how you write. So now you can equate these two. Okay, so pressure at C should be equal to pressure at C dash. So that is how, so here I have written is, so this is left hand side, which is pressure at C, and right hand side is pressure at C dash. So simplify this, so bring this to this side, so you will get pressure PA minus PB, which comes to, so you bring this to the right hand side, so it will become minus 11.97, or you can write PB minus PA as plus 11.97. So pressure at B is more than pressure at A.
So since we have taken PA minus PB, it is coming minus 11.96. You can also write as PB minus PA, which is plus 11.97. So that is how the difference of pressure. So here you need not plot this diagram. So this diagram is given all these distances are also given in the problem. So only thing is you have to identify where the pressures are same, and based on that you should start from pressure points and move up to C, and start from pressure point PB and move up to C dash. So then you can equate these two so as to solve the problem. So like this you should identify problems. And here also, here again in a left leg of YouTube manometer connected to a pipeline. So here the water is there. So level of mercury in the leg being zero point 0.6. So here when you expose to the atmosphere, it will be okay. So there will be no difference in the mercury level, but once you connect it, so this mercury gets displaced. So that's what written here. So therefore the level of mercury in the left limb is 0.6 meters below the center line of the pipe. So therefore this is marked, and the right leg is open to atmosphere. Okay, the level of mercury in the right limb is and the right leg is 0.45 meters above that of the left leg. So here the level of mercury, so it has to be 0.45 above the left limb. So therefore this 0.45 is marked. Then we have the space above the mercury is filled with benzene having specific gravity 0.88 for a height of 0.3 meters. So you note that 0.45 plus 0.3 is more than 0.6. So therefore this has gone above this point A. So when you write this is the diagram that you are supposed to write. So depending upon this statement, so we have to find the pressure at a point. So this is known as a U-tube manometer, which is connected. So once we connect this U-tube manometers, the water enters and displaces. So this mercury is displaced such that it is 0.6 meters below point A in the left limb. In the right limb, the mercury level is 0.45 above that of the left limb. So therefore 0.45 is marked, and above points C, that is above mercury, there is benzene of specific gravity 0.88 of height 0.3. So here again, once again, this is one continuous liquid. So therefore the pressure at B has to be marked equal to pressure at B dash. You start from A and move down towards B. Start from D where pressure is 0 because it's exposed to atmosphere, and come down to point B dash and equate these two, so you will get the answer. So pressure at B has to be equal to pressure at B dash. So now we start at A, which is pressure at, because it is a pressure point, so PA. So as we move downwards, okay, the pressure increases. So 9.81 into 0.6, because 9.81 is for water. So now you start from D where pressure is 0. So benzene, because 0.88 into 9.81 is specific weight, multiply by 0.3 for the height. Then as we move downwards, pressure increases. So plus sign 13.6 because it is mercury. This is mercury. 13.6 into 9.81 into 0.45. So only unknown is pressure at A. So that gets solved. So therefore the pressure at A is 56.74 kilonewton per meter square. So writing the figure is very important in this problem. So the statement will be given to you and you are supposed to write. Okay. So here this is a pipeline which is running perpendicular to the screen. So therefore when I take a section, so the cross section is given. So circular pipe which is running, okay, perpendicular to the paper or screen. So therefore a YouTube manometer is connected here. So once you connect this YouTube manometer to this pressure point, so the liquid, that is water, comes and displaces the mercury and benzene which was there in the manometer. So therefore you have to be very careful here. So how it gets displaced, and those distances are given to you. So another problem where a YouTube differential manometer. The last problem was a simple manometer, YouTube manometer, where pressure at a particular point is determined. Here, whenever there is a difference of pressure, then YouTube differential manometers are connected. In the previous problem, one limb was exposed to atmosphere, whereas here it is connected to the pressure points, both the pressure points. So that is what is, so this is the problem. So here we have, so one pipe is A, which is containing carbon tetra. So this is, we have to be very careful in writing this. So which is under a pressure of 120. So here pressure E is given 120, whereas in the other limb oil is flowing. So where the pressure at B is 200. So once the pressure here is 200 and here 120, so therefore I have the liquid in this limb, here it moves down and it comes up. Okay, so therefore you have to show this this point has to be lower than this point. So therefore you have to be very careful, because here it is 200 kPa and here it is 120 kPa. So the pressure at B is more than the pressure at A. So it is given that the pipe A lies 2.5 meters above pipe B. So therefore this is marked, and the mercury level in the limb containing A is 4 meters. So this mercury level is shown at a distance of 4 meters below the center line of the pipe. So once this is 4 meters and this is 2.5, so this distance has to be 1.5 meters up to C. So here what is the difference of the mercury level is asked. So this is, so you cannot bring this D dash above and C below. So you have to be very careful that the pressure at B is more than pressure at, so it has to go down and this has to move up. So we are required to find the difference of the mercury level. So here we can see that this one continuous liquid, so pressure at D has to be equal to pressure at D dash. So how to write? So pressure at D is 120, which was kilopascal. So now coming down plus sign. So here it is carbon tetrachloride. So 1.6 into 9.81 into 4. So now we have come up to C only. So we have to go down again to D. So again plus sign. So 13 point, because it is mercury. So 13.6 9.81 into H. So we have come to point D. So now start from 200 kPa, that is at B. So pressure will be 200. As we move downwards, pressure increases, so oil is flowing, so 0.8 into 9.81 into 1.5. Again when you move from here to here, it is again oil, so it is plus, so 0.8 to 9.81 into H. So knowing all the quantities, only H is unknown here, so you can solve for H. So writing this equation is very important, and writing this diagram is also very important. So therefore H is 0.231 meters. So the difference in the mercury level is 0.231 meters. So inverted U-tube manometer is connected to the two horizontal pipes A and B, through which water is flowing. Here the pressure points are A and B. So the vertical distance between A and B is 30 centimeters. So when oil of specific gravity 0.8 is used as a gauge liquid, so here the manometric liquid is oil, so its specific gravity is 0.8, which is less than the specific gravity of the liquid that is flowing in the pipes. So here water is flowing, so specific gravity is 1. So therefore here the gauge liquid has to be, specific gravity of the gauge liquid has to be less than 1. So therefore oil is used. The vertical height of water columns in the two limbs, in both the limbs, that is left and right limb, is same and is equal to 35 centimeters. We have to find the difference of pressure between point A and B. So pipe B is lying below pipe A. So this is the sketch. So when the way we have here pipe A, which is here where the water is flowing, and again we have pipe B where again water is flowing. So this difference between these two pipes is 0.3 meters, and we have said that the pipe B is lying below pipe A, and the difference of the water columns and the vertical height of the water columns is 0.35 meters. Similarly here again, here also it is same, which is 0.35 meters. So therefore whenever this water enters, it displaces the liquid. So therefore we have this distance as the difference in the oil levels between the two limbs. So that will be, so 0.3 plus 0.35 is 0.65, 0.65 minus 0.35 is 0.3 meters. So CD dash is 0.3 0.3 meters. So we know that it is one continuous liquid and also it is one plane. So therefore the pressure at D should be equal to pressure at D dash. You start from A and move upwards. So as we move upwards, pressure decreases. So pressure here is PA. So minus, so here it is water, so 9.81 into 0.35. So similarly take pressure B, then go up by 0.35, it is water, so 9.81 into 0.35. Then again here it is oil, which is 0.8 and 9.81 into 0.3. So solving, you will get the difference of pressure. So now pressure at D should be equal to pressure at D dash. So we know that PA, so pressure at D is PA minus 9.81 into 0.35. Similarly, pressure at D is PB minus 9.81 into 0.35, and CD is 0.3. So but it is oil, so minus 0.8 into 9.81 into the distance, which is 0.3. Now solving for PA minus PB, we will get minus 0.2354 kilonewton per meter square. So therefore the pressure at B is more than pressure at A. So you can also write PB minus PA as 2 plus 2.354 kilonewton per meter. So the next problem is that a petrol is flowing in a vertical pipe. So petrol specific gravity is 0.8. So A and B are the points in the vertical pipe itself. So A and B are the two pressure points. But we know that point B is 0.3 meters higher than the point A. So connections are taken from A and B and connected to U-tube manometer, which is containing mercury. So the difference of pressure between A and B is 18 kPa, kilopascal. You have to find the reading of the difference. Reading of the differential manometer is nothing but difference of the mercury levels. So here we have the pipeline where the pressure points A and B, they are separated by distance 0.3 meters. We know that the point B is higher than point A by 0.3 meters. We are connecting the manometers to the 2 points. So whenever we connect, the petrol enters the manometer and displaces the mercury. So therefore here the difference of the mercury level is to be, which is H. So now we start from, so here it is one continuous liquid, the pressure at C should be equal to pressure at C dash. So start from A, so that is PA. So here it is petrol, so specific gravity is 0.8, so 0.8 to 9.81 is specific weight into H is the distance. So now you can start from B, so that is PB. So as we move downwards, pressure increases, so plus sign. So we have 0.3 meters of petrol, so it is 0.8 to 9.81 into 0.3. Then we have mercury, which is 13.6 into 9.81 into H. So therefore it is written like this into H. So solving, so we know that PA minus PB is nothing but 18 kPa. Substitute, so that's solve for H. So you will get H as 0.125 meters. So a differential manometer is connected between 2 points. In the last time we took as a vertical pipeline, now we have 2 points in an horizontal pipeline. So we connect to the 2 points A and B. Okay, but the pipe is carrying oil of relative density. Relative density is specific gravity, which is 0.8. So when it is connected, the difference of the mercury level is given, which is 0.225 meters. Last problem, pressure was given, difference of pressure was given. In this problem, we are required to find difference of pressure, but the difference in the mercury level is given. So now here the oil is okay flowing. There are 2 points where we are connecting. So we know that as we the liquid flows, so pressure here A will be more than pressure because there is always loss. So pressure at A, because pressure at A is more, so this level goes down and this level comes up. So the difference in the level, mercury level, is 0.225 meter. So here the distance is not given, take it as Y. So here oil flows and displaces. Similarly here oil flows. So now we know that pressure at D should be equal to pressure at D dash. So therefore we start at A, so PA. So we come down by Y, but oil is so 0.8 and 9.81 into Y. So like that. So as we move downwards, pressure increases. So then again we move down by 0.225 to reach D. So again 0.8 into 9.81 into 2.225.
So that should be equal to, so pressure at B. So as we move downwards, so Y again we have oil, so 0.8 to 9.81 into Y. So then here for a distance of CD, so it is mercury, so 13.6 into 9.81 into 0.225. So here, so since this distance need not be given because it gets cancelled out. If there are same liquid in both the limbs, so it gets cancelled out. So therefore now the difference of pressure is to be determined. So PA minus PB is asked, which comes to 28.25 kilonewton per meter square. So writing the sketch is very important given the data, and they'll tell you to find either the difference of pressure will be given and tell you to find the difference of mercury level, or difference of mercury level will be given and tell you to find the difference of pressure. So now they have asked what is the difference of pressure between 2 points in terms of height of water. So if you divide this by specific weight of water, you will get meters of water. So therefore H has to be, if you divide by 9.81, it will be in meters of water. So that is height of water. So it is 2.88 meters of water. So next problem is for a gauge reading of 200 kilonewton per meter square, what is the total weight should be placed at A, including the weight of the piston. So here the problem is that, so here for a gauge reading, so for example here this is gauge which is fitted, which reads 200 kilonewton. So here weight as well as the piston is, so we have to find out what should be the total weight that is to be placed, okay, here at A. So including the weight of the piston. So now here 2 meters diameter is given here, and this, okay, and the difference is given as 2 meters, the distance is given as 2 meters. So this you have to note that. So now you know that this is all oil of specific gravity, so the pressure along this plane should be same. So pressure at C should be equal to pressure C dash, because it is one continuous liquid. So now what is the pressure here? It is the total weight that is exerted divided by the, so pressure is force divided by area. So W, you let the weight be W, so weight divided by pi by 4 d square gives the pressure. So the pressure is known here, so that has to be equated here. So 200 is the pressure here, 200. As we move downwards, pressure increases. So oil, so 0.9 into 9.81 into 2, so therefore we can find out W. So this is what is the answer. So pressure at C should be equal to pressure at C dash. So weight divided by A should be equal to, that is pressure is equal to 200. As we move downwards, pressure increases, so 0.9 to 9.81 into 2. So therefore the pressure is 217.658 kilonewton per meter square. But W, if you multiply by area, pi by 4 d square, so therefore you will get the force in kilonewtons. So therefore the weight that is to be including the weight of the piston has to be 683.45 kilonewtons. Okay, now we are in the accompanying figure. The plunger A is 40 centimeter square, whereas cylinder B is 4000 centimeter square, where weight of B is 41 kilonewtons. Find the force required for the equilibrium if the weight of A is neglected. So now here this is the problem where we have the cylinder, this is the cylinder and this is the plunger. So where we have to find out what is the force have to be applied. So we know that it is one plane here, horizontal plane, and the liquid is same. So pressure at C should be equal to pressure at C dash. So that is what is to be understood. So now F divided by A, but area of the plunger is 40 centimeter square. So you can divide by 100 square to convert to meter square. So therefore F divided by A. So plus, so we have to come down here because specific weight of oil is 0.75, 9.81 into 0.05 is this. So we'll get here is, this is the weight. So weight of B is 41 kilonewton divided by the area. So area is 4000 centimeter square. That if you divide by 100 square, so you will get 0.4. So therefore area is 0.4. So 41 divided by 0.4. So now if you solve for F by A, it will come to 102.132, which is kilonewton per meter square. If you multiply by the area of the plunger, we'll get the force. So the area of the plunger is 40 centimeter square. So 40 centimeter square divided by 100 square will give you in meter square, which is 0.004. That gives the answer as 0.4085 kilonewtons or 408.5 newtons if I'm after multiplying by 1000.
So in this last problem, we have the very good problem, which is where we have a simple mercury manometer. So where one end is connected to a conical vessel. So the manometer reading is showing 20 centimeters when water is filled up to A. So what will be the new manometer when the vessel is completely filled with water? So here the problem is like this. So this is when the here this is one end is open to atmosphere, so other end is connected to a the conical flask. The conical flask dimension is 3 meters. Here this diameter is 1 meter. So but water is only up to this level. When you fill water up to this level, so here due to this water, so there will be difference in the mercury level, which is shown as 0.2 meters. Here so we don't know this distance why, so that's the reason why, since the water is to this point, so we are required to find out. Okay, now you know that it is exposed to atmosphere, so pressure here will be 0. So as now it is one continuous liquid, so therefore pressure at B dash has to be equal to pressure at B. So by doing this you can find out this answer y. So that's why let y be the height of the water column, which is not given, so therefore we are required to find out. So when the vessel is empty, so pressure at B dash is equal to pressure at B. So now you know that this is also exposed to atmosphere, here also exposed to atmosphere, so it will be 0 plus 13.6 into 9.81 into 0.2. So that is how it is, and here it is water, so it is 9.81 into y. So that gives the answer for y, which is 2.72. So now when you try to fill this, okay, when you try to fill this, let the diagram be same. So I maintained this B, so this is B dash, this is B dash. So earlier case it was from C, so here this C, which is 0.2 meter, same diagram written. When you fill this water here, so now again it will push the mercury level by an amount H to D, and it will again here it will come up by the same amount H, but this will this is 0.2 which is taken from here, so the new manometer reading will be 0.2 plus H plus H. So because of this water filling for 3 meters height, the mercury level from B will come down to D, whereas the mercury level from C will go up by the same amount H. So a new manometric reading when the vessel is filled with water will become 0.2 plus H plus H. So therefore now here it is one continuous liquid, so pressure at D dash has to be equal to pressure at D. So you start from here because here we are liquid, so here it is exposed to atmosphere 0, so 9.81 into 3 plus y, so y up to here, which is the same distance, which is 2.72, so it is 9.81 into 2.72 plus 9.81 into h. So again here it is 0, so h 13.6 into 9.81 into h plus 13.6 into 9.81 into 0.2 plus 13.6 into 9.81 into h. So this is how you write. So when vessel is completely filled with water, so pressure at D dash has to be equal to pressure at D. So that's how that is. We start from left limb 13.6 into 9.81. So distances is h plus 0.2 plus h. Okay. So here pressure at D will be, we start from, okay, top. So 9.81 is full of water up to D. So that gives, so 9.81 into 3 plus y plus h. So y is 2.72. So substitute and solve for h. So therefore h has to be 0.1145 meters. So therefore the new manometric reading is 0.2 plus h. So that gives 0.429 meters. So these are the problems that are there, which is using the concept of pressures. So I use the concept where dou P by dou X should be equal to 0. So pressure is constant along the horizontal line. As we move up, pressure decreases. As we move down, pressure increases. Using this concept only, you should write the expressions. So when one limb is exposed to atmosphere, the pressure is 0 at the surface, and when it is connected to a pressure point, definitely the pressure has to be some value, so which is PA or PB or anything. When a differential manometer is connected, you should see that it is connected to pressure points A and B, where we are required to find the difference of pressure, or given the difference of pressure, you should know how to find out the difference in the manometric liquid. So whenever you say that inverted U-tube manometer is used, you have to see that gauge liquid of the inverted U-tube manometer has to be always specific gravity of that liquid has to be always lesser than the liquid that is flowing. So you have to be very careful in these concepts so that you will when you solve such problems, you will understand each of the problems and you will write the manometric equations. So read my or listen to my lecture number 3 for the concepts, and also solve the problems which are covered in lecture number 4. So the next topic that I am going to cover is hydrostatic pressures on plane surfaces as well as on the curved surface. Look out for my new video lectures on hydrostatic pressures on plane surfaces as well as on the curved surfaces. Thank you.